Hi everyone, today we'll be looking at how to apply the idea of the Pythagorean theorem to word problems. This is today's focused learning target. Given a word problem, I will be able to apply the concept of the Pythagorean theorem to visualize and solve the problem. So today we'll be learning how to apply the Pythagorean theorem to real-world scenarios. Before we look at examples, let's quickly review the Pythagorean theorem. So say we have a right triangle with the legs A and B and the hypotenuse C. The Pythagorean theorem states that A squared plus B squared equals C squared. The sum of the two legs squared equals the hypotenuse squared. Let's also quickly review directions, since you'll be seeing some word problems that involve these. Think of going north as going up. And then going to the east is like going to the right. And if you're heading south, you're heading downwards. And lastly, if you're going west, you're going to the leftwards direction. And a good way to remember this order, north, east, south, west, is never eat soggy waffles. We'll be looking at 3 examples today, and although the example problems are a bit lengthy, please make sure you write them down in your notes. So here's our first example. Please pause so that you can write the entire problem down. So we drive north for 32 miles, turn right, and drive east for another 24 miles. At the end, what is your straight line distance from your starting point? So our first step is to visualize this problem. And visualizing the problem is actually probably the most important step because it will help us set up and solve for the problem. So the problem tells us that you drive north for 32 miles. So we start at a point and we're driving north for 32 miles. So think of it as driving upwards for 32 miles. We drive up north for 32 miles. So let me label this side. So it's 32 miles here. And then we turn right and drive east for another 24 miles. So we go right for 24 miles. So let me write this distance right here, 24 miles. So we started at that bottom point and ended here. And the problem asks us, what's the straight line distance from your starting point? So what is this straight diagonal length distance starting from our starting point and going to the end point? We want to find this distance using the Pythagorean theorem. So how can we do that? Well, now that we've visualized the problem, we see that this problem actually creates a right triangle. So like this, we have the right triangle shape. We have the right angle right here. So what are the triangle's legs? And what's the hypotenuse? The driving north and driving east gave us our legs for this triangle. So I'm going to label them A and B. So A equals 32, B equals 24, and C is the unknown hypotenuse. So let's solve for C using the Pythagorean theorem. A squared plus B squared equals C squared. We know A equals 32. So 32 squared. B is 24, so 24 squared. And you can use a calculator. I definitely did. So 32 squared equals 1,024, and 24 squared equals 576. Let's add the values together. We get that 1,600 equals C squared. Notice I have this square So I'm going to take the square root of both sides. And we find that c equals 40. We have a perfect square. But what does the c represent? Why were we solving for c? So c represents the straight line distance from our starting point to the ending point. So that diagonal line is 40, and we think of the units. Since our units are in miles, we know that this distance is 40 miles. So go ahead and pause and review this example as many times as you would like to. For these word problems, again, the most important step is to visualize and set up the problem. So here's our next example, and remember to write down the problem in your notebook as well. So let me read it as well. John's 11-foot pet monster casts a shadow. So obviously not like a real life scenario, but you know. From the end of the shadow to the top of the monster's head is 12 feet. How long is the monster's shadow? So try visualizing this in your head and try to imagine what this would look like. So in this problem, John has an 11-foot pet monster. So here's a pet monster. Google image, yay. And I know that this monster is 11 feet tall. So it has a height of 11 feet. And it casts some kind of shadow, but we don't know how long that shadow is. But we do know that from the end of the shadow to the top of the monster's head is 12 feet. So from the end of the shadow to the top of the monster's head, this is 12 feet. And the problem asks for the length of the shadow. So how long is this length right here? So we visualized the problem and kind of sketched it out. And notice how we have a right triangle here. Which sides are the legs and which side is the hypotenuse? Well, for this problem, we have one unknown leg, the other leg is 11 feet, and we know the hypotenuse is 12 feet. So from here, we can set up our problem and solve for it using the Pythagorean theorem. So we don't know what a is, so we'll leave it as a squared, but b is 11, so 11 squared, that equals 12 squared, because c equals 12. And so from here, we're going to solve for a step by step. So first, let's just square it out. 11 squared is 121, 12 squared is 144. And we want to isolate the a, so we're going to subtract 121 from both sides. Cancels out, and we have that a squared equals, so 144 minus 121 equals 23. We take the square root of both sides, so a equals the square root of 23, which is approximately 4.8. So we've solved for a, but what does this value mean? In this problem, we were trying to find the length of the monster's shadow, which is in feet. So that's why our final answer is 4.8 feet. The shadow of the 11-foot monster is 4.8 feet. Let's walk through one more example together. So in this example, we have a TV. So a certain television is advertised as a 29-inch TV, the diagonal length. If the width of the TV is 20 inches, what is the height of the TV? So I have a TV here with a 29-inch diagonal length. So whenever you see TV ads and it's like however many inches, That's talking about this diagonal length of the TV screen. So in this case, this length is 29 inches. And we're also given the width of the TV, which is 20 inches. So this way, the width is 20 inches. And we're asked to find the height of the TV. So how tall is the TV? This is our unknown value. So let's set up this problem. The hypotenuse is that diagonal length across from the right angle, and we have the two legs. We know one leg length, but not the other, and that's actually what we're solving for here. So let's set A equal to 20, B as the unknown, and C is the hypotenuse, 29 inches. I'm writing out the Pythagorean theorem here. And let's plug in the values we know. So 20 squared plus B squared equals 29 squared. 20 squared equals 400 plus the B squared equals 29 squared is, and I'm using my calculator here, so 29 squared equals 841. From here, let's isolate B. I subtract by 400 on both sides. This cancels out. I'm left with B squared equals 441. Next, I'm going to take the square root of both sides, like this. And 441 is a perfect square, so B is exactly equal to 21. And B represents the height of the TV screen, which in this case is measured by inches. So we've solved for this height of the TV, and the height is 21 inches. And we were able to solve for this missing height by setting this problem up and visualizing the right triangle, and then using the Pythagorean theorem. So in general, for these word problems, the most important step is to visualize the word problem itself. Like, what would this look like? In our first example, it was a driving distance type of problem. And then in our second example, we had a pet monster and its shadow. And in this example, we had a TV screen. So the most important step is to read that problem and to visualize what it would look like, and then setting up the problem based on that visualization. Just as a review, the Pythagorean theorem states that for any right triangle with legs AB and hypotenuse C, A squared plus B squared equals C squared. When looking at word problems, make sure you're correctly labeling the legs and the hypotenuse. Please remember to submit your notes on Canvas, and great job today.